Hi everyone, and so today we are going to see lecture number 8. So we have completed up to lecture number 7. So in the last lecture we have started with cylindrical coordinate systems, right? So we have seen what do you mean by rho, what do you mean by phi, what do we mean by z, and also we have seen how to represent the rectangular coordinates in terms of cylindrical coordinates and cylindrical coordinates in terms of rectangular coordinates. And also we have seen that this unit vectors aero cap, a phi cap and az cap, right? So these are az cap will be same as what? Az cap will be same as az cap only, whereas aero cap and a phi cap are depending upon what? Are depending upon phi. So as phi varies, the direction of aero cap and a phi cap are also changing. So how they are going to depend upon phi? So that's what we have derived. Yes or no? So we got aero cap as cos phi ax cap plus what? Plus sin phi ay cap, and we got a phi cap as minus sin phi ax cap plus cos phi ay cap, and az cap will be same as what? Az cap is same as az cap only. So this is what we have seen, right? So I have explained you a method to determine this aero cap and a phi cap. Understood? And also I have told that I am going to explain another method to determine this aero cap and a phi cap, right? Okay. Yeah. So now see here, if you consider the cylinder, let us consider a cylinder here, let us say cylinder. Okay. So I am explaining another method to write the aero cap and a phi cap here, right? See, this analysis is very, very important, right? Okay. Okay. So let us say this is the cylinder, and here this is a axis of the cylinder, that is z axis, and this is we have considered as x axis, and this is z axis, and this we have considered as y axis, right? Okay, fine. Now aero cap, that means rho is nothing but what? The normal distance from the axis of the cylinder to any point on the surface of the cylinder. So this is the axis of the cylinder, right? Okay. So this is nothing but aero cap. Okay. So what is a phi cap here? The tangent drawn at this point in anti-clockwise direction is nothing but what? Is nothing but a phi cap. And if I draw the normal to this one, so this is nothing but what? This is nothing but az cap. So aero cap is radially outward, a phi cap is tangential, az cap is pointing upward direction. Understood? Okay. Yeah. So now here, if I consider this circle here, if I consider this bottom circle, so here also aero cap is going to point in this direction, and a phi cap is the tangent drawn to this, tangent drawn at this point. Okay, I am just drawing rough diagrams here, right? Okay, so this is a phi cap, and here this is nothing but what? This is nothing but az cap. Now if you observe, this aero cap and a phi cap, are lying in which plane here? They are lying in xy plane. Yes or no? So this plane, these circles here, these circles are nothing but what? Are nothing but the planes that are parallel to what? That are parallel to xy plane. Yes or no? So these circular planes are parallel to what? Are parallel to xy planes. So if you observe here, aero cap and a phi cap are lying in this plane. Yes or no here? So they are lying in xy plane. So which means aero cap and a phi cap are lying in xy plane, means aero cap and a phi cap are going to have only x component and y component. Understood? Okay. So az cap is perpendicular to what? Perpendicular to this xy plane, right? So that's what we can observe here. So what we have observed here, so aero cap and a phi cap are lying in what? Lying in planes, in circular planes. Yes or no? They are lying in circular planes parallel to what? Parallel to xy plane, parallel to xy plane. Yes or no? So these are the circular planes that are parallel to what? Parallel to xy plane. Aero cap and A5 cap are lying in xy plane, right? Okay, okay. So now if they are lying in xy plane, they are not going to have what? These are not going to have any z component. They are going to have only x component and y component. So aero cap and A5 cap are going to have what? Are going to have only x and y components. Are going to have only x and y components, right? Okay, okay. So now now if I want to determine the component of aero along x, right? So the component of aero along x is going to give you what? Is going to give you x component of aero, right? And similarly I can determine the component of aero along y. Understood? And here A5 cap also we can determine the component of A5 cap along x, and also we can determine the component of A5 cap along y. See here what we got? We have already derived this aero cap and A5 cap. What we got? Aero cap is having x component and it is having what? Y component. And A5 cap is also having what? X component and it is having what? Y component. It is having only x and y components. So this is the cos phi. Cos phi is the x component of aero cap and sin phi is the y component of aero cap. And here minus sin phi is the x component of A5 cap, and here cos phi is the y component of A5 cap. Understood? Okay. So we have to determine the component of aero cap along x direction and along y direction. Similarly, we can determine the component of A5 cap along x and y directions. Understood? And we know how to determine the component of one vector along the other, right? Okay, okay. So we know that aero cap and A5 cap are lying in xy plane, and what is the angle between aero cap and A5 cap here? They are mutually perpendicular to one another. So the angle between aero cap and A5 cap must be 90 degrees, and also we know that aero cap cross A5 cap must be equal to what? Must be equal to AZ cap. So these three are mutually perpendicular to one another, and if you do aero cap cross A5 cap, you are going to get what? AZ cap. So keep all these points in mind here, right? Okay, okay. So now see here. So this is let us say this is y axis. Let us say this is y axis, and let us say this is x axis, right? Okay, okay. So now here I am considering, we know that aero cap and A5 cap are going to lie only in xy plane, and the angle between aero cap and A5 cap must be 90 degrees, and if you do aero cap cross A5 cap, it has to point in AZ cap direction. Understood? So this is x axis, this is y axis. So if you curl your right hand four fingers from x to y, okay, so the thumb is pointing out of the board, so that means z axis is pointing out of the board, right? Okay, fine. So now I am considering here aero cap here. Let us consider here aero cap, right? Aero cap. Now now I have to draw A5 cap such that the angle between aero cap and A5 cap must be 90 degrees, and if you do aero cap cross A5 cap, then it has to point in positive z direction. Understood? Aero cap cross A5 cap must be equal to AZ cap. So which means I can draw A5 cap like this, right? So this is A5 cap, and the angle between these two, is 90 degrees, and if you do aero cap cross A5 cap, the thumb is pointing along AZ cap direction. Understood? So everything is valid, right? Okay. So graphically we are trying to determine this aero cap and A5 cap in terms of phi, right? Okay, okay. So now see here. See, we know that the angle between aero cap and x axis, the angle between x axis and aero cap is how much here? The angle between x axis and rho is nothing but what? Phi or not? Yes or no? So this angle is nothing but what? This angle is nothing but phi. Right. Okay. Okay. Next, what is the angle between y-axis and x-axis here? This angle is nothing but 90 degrees. This angle is nothing but 90 degrees. Right. Okay. Next, what is the angle between a phi cap and x-axis? What is the angle between a phi cap and x-axis? This angle is 90, this angle is phi, so this angle is nothing but 90 plus phi, right? Okay. And one more thing, see, if we know the angle between aero cap and x-axis, we can find out the x component of aero cap, and if you know the angle between aero cap and y-axis, you can find out the y component of aero cap. Similarly, if you know the angle between a phi cap and x-axis, you can determine the component of a phi cap along x. Similarly, if you know the angle between a phi cap and y-axis, you can determine the component of a phi along y direction. Understood? So it is as simple as that. So that's why I am trying to write all the angles here, right? So the angle between a phi cap and x-axis is nothing but 90 plus phi, and the angle between aero cap and x-axis is phi, right? Okay. And the angle okay, right. So the angle between aero cap and y-axis, the angle between aero cap and y-axis, this angle is nothing but what? This angle is nothing but 90 minus phi. This angle is nothing but 90 minus phi, right? So we know the angle between aero cap and x-axis, and we know the angle between aero cap and y-axis, and we know the angle between a phi cap and x-axis. And what is the angle between a phi cap and y-axis here? What is this angle? Tell me. Tell me, what is this angle? See, this angle is this total angle. This total angle is 90 plus phi. This total angle is 90 plus phi, right? Okay. This angle from here to here, what is the angle? 90 degrees. So this angle is what? This angle is 90 degrees. So this total angle is 90 plus phi, and this angle is 90. So this angle must be what? This angle must be phi. Now we know the angle between aero cap and x, aero cap and y, and we know the angle between a phi cap and x and a phi cap and y. So just we have to determine the component of aero cap along x and y, right? In the same manner, we have to determine the component of a phi cap along x and y. So it is as simple as that, right? Okay. Okay. So once you have understood these things, then it is going to be very, very simple, right? So aero cap is equivalent to, so it is going to have x component, right? So its x component means x component has to point in which direction? Ax cap direction, plus what? Plus you must have y component, right? Okay. Okay. So y component. So it is going to have x component and y component. Now similarly, a phi cap must also have its x component, right, and y component, right? Okay. Okay. So now see here, see the angle between aero cap and x-axis is how much here? Is nothing but phi. So what is the component of aero cap along x here? What is the component of aero cap along x? Is nothing but what? Aero cap dot what? Dot ax cap, which is equal to what? Aero cap dot ax cap is nothing but what? Is nothing but magnitude of aero cap multiplied by magnitude of ax cap multiplied by what? Angle between these two, that is nothing but what? Cos phi, right? See, whenever you are doing the dot product between two unit vectors here, okay, so the magnitude anyway it will become 1. Just write down cos of angle between those two, that's it. That is going to give you the component. Okay, so there is no need to write every time this step. Okay, whenever you are doing the dot product between two unit vectors, so magnitude will be always 1. So write down simply cos of angle between those two unit vectors, right? Okay. So now here if you want, you can represent this as ax cap, right? Ax cap is pointing in this direction and ay cap is pointing in this direction, right? Okay. So aero cap. So x component, what is the x component here? What is the x component? What is the x component of aero cap? Is nothing but what? Is nothing but what? Is nothing but cos of what? Cos of angle between aero cap and ax cap. That is nothing but what? Phi. So simply write here cos phi. That's it. Next, you want the y component of aero cap. What is the y component of aero cap here? So just see the angle between aero cap and ay cap. What is the angle between aero cap and ay cap? Is nothing but what? Is nothing but 90 minus phi. So simply write cos of 90 minus phi. That's it. So cos of 90 minus phi is nothing but what? Is nothing but sin phi. Right. Next, coming to a phi cap. Okay. So what is the x component of a phi cap? What is the component of a phi cap along x here? What is the component of a phi cap along x? What you need? You need the angle between a phi cap and ax cap. What is the angle between a phi cap and ax cap here? Is nothing but 90 plus phi. So what I have told, simply write cos of what? Cos of 90 plus phi. So what is cos of 90 plus phi? So here I am writing cos of what? Cos of 90 plus phi. So cos of 90 plus phi is nothing but what? Is nothing but minus sin phi. Right? Okay. Next, what is the angle between a phi cap and ay cap here? Is nothing but phi. So what is the component of a phi along y here? Is nothing but what? Is nothing but cos of phi. Right? So simply write down here cos phi. Right? So therefore we got aero cap is equal to, we got cos phi ax cap plus what? Plus sin phi ay cap, and then a phi cap is equal to what? Is equal to minus sin phi ax cap plus what? Plus cos phi ay cap. So whatever we got here, so the same thing we got here also or not by this method. Understood? Okay. So this is just another way to represent aero cap and a phi cap here. Right? Okay. So if you want, you can follow this method also. So this is, I can say this is second method. So if you don't want all these things, if you are feeling somewhat difficulty in representing these angles and all, okay, if you are feeling somewhat difficulty in representing these angles and all, so then you can follow the first method itself. Right? Okay. Okay. Right. So if you practice, this is going to be very simple here. This is going to be very simple. But if you do any simple mistake here while taking the angles, if you do any simple mistake here, then there is a chance that you will get some wrong answers. Right. So that's why you can follow the first method. So if you follow first method, there is less chance of doing mistakes. The probability of doing mistake is very, very less if you follow first method. Right? Okay. 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 So this is just you have to analyze each and everything here. Your thought process has to develop. Understood? So that's why I am explaining all these things. Right? Okay. Okay. So I hope it is crystal clear. Right? Okay. Then next. So we have seen how to represent this aero cap and a phi cap. So az cap is same as what? Az cap is same as az cap only. Right? Okay. Next here. Next. See here. Now we try to represent the differential areas and differential volumes. Right? Okay. Okay. So differential volume, not volumes, differential volume. Right? So for that, what we have to do? So first of all, write down the differential lengths in cylindrical coordinate system. So what are the differential lengths we got here? We got the differential lengths as d rho aero cap. Okay. So this is along a straight line path. So d rho aero cap. Next, rho d phi a phi cap. So this is differential arc length. So this is the movement. As phi varies, you are going to move along the circumference of the circle. So the differential arc length, you are moving along a curved path. So that is the differential arc length along phi is nothing but what? Rho d phi a phi cap. So next one is what here? A dz az cap. So these are the three differential lengths you are having in cylindrical coordinate system. So with the help of these three differential lengths, we can form what? We can form three differential areas. Understood? So follow the same procedure here, whatever we have followed in the rectangular coordinate system, the same procedure you can follow here also. right? Okay. So what is the first differential area? dA1 bar is equivalent to what? Is equivalent to, how you can form the differential area? Do the cross product between any two differential lengths. So if you do the cross product between these two differential lengths, what you are going to get? D rho A rho cap cross what? Cross rho D phi A phi cap. So this is equivalent to, so what is the magnitude? Magnitude I can write it as rho D phi. This is the magnitude. What is the direction? A rho cap cross A phi cap. A rho cap cross A phi cap is nothing but what? AZ cap. So if you observe here, the variables are nothing but what here? Here the variables are nothing but rho and phi. The variables are nothing but rho and phi. So that means Z is constant. So we call this plane as what here? We call this plane as a Z is equal to constant plane. So for Z equal to constant plane, what is the direction? It is in AZ cap direction. So why it is in AZ cap direction? Because you are enclosing the surface from where to where? From A rho cap to what? From A rho cap to A phi cap. Understood? So under this condition, the direction of the surface will be in AZ cap direction, right? So this is called as a Z is equal to constant plane. Z equal to constant plane. So on Z equal to constant plane, what are variables here? Rho and phi are variables. Understood? Okay. Okay. So now see here. So what is the total surface you are going to get here? What is the total surface you are going to get if you vary rho and phi? If you vary rho and phi, what is the total surface area? That means I am asking, what is the shape of the surface that you are going to get by varying rho and phi? By varying rho and phi, what is the surface? What is the surface you are going to get? Okay. See, without doing any mathematical analysis, okay, so just with our visualization, you can easily tell the shape of what? The shape of the surface, right? Because we know what do we mean by rho and what do we mean by phi. We know these two things, right? So with the help of that, we can easily tell the shape of the surface, right? See here. So let us say this is Z axis here. Let us say this is Z axis, right? Let us say this is Z axis. Okay. So now what you have to vary? Rho and phi. Rho and phi. So by varying rho and phi, what is the surface that you are going? What is the surface that is going to form? Okay. So that's what we have to check. So now vary rho and vary phi. Vary rho and vary phi. Vary rho and vary phi. Vary rho, vary phi. I am removing this here. Assume here Z axis is present. Vary rho and vary phi. 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 So what you are going to get? You are going to get a circular surface or not? Yes or no here? So it is just like if you take a pan and if you put what here? Batter, that dosa batter or something. Okay. So if you put on the pan, then if you do like this, what you are doing? You are increasing rho and also you are changing phi. What are changing here? Rho and phi are changing. Rho is changing and phi is changing. Rho is changing and phi is changing. Rho is changing and phi is changing. So finally what you are going to get? You are going to get a circular dosa, isn't it? Okay. So if you vary rho and phi, vary rho and phi, vary rho and phi, vary rho and phi, you are going to get the circular surface. Understood? Okay. So if you draw a normal to that circular surface, so it is going to point in which direction? AZ cap direction. Understood? See, it is just like this one. See here. So this is the surface you are going to get, isn't it? Okay. So by varying rho and phi, by varying rho and phi, by varying rho and phi, you are going to get what? You are going to get the surface of the circle, the surface of the circle. And if you drop the normal, if you draw the normal to this surface, it is going to point in AZ cap direction. So we are assuming that we are enclosing the surface from A rho cap to A phi cap. So A rho cap is going to point in this direction and A phi cap is going to point in this direction. So if you enclose from A rho cap to A phi cap, it is pointing in which direction? AZ cap direction. So everything is valid, right? Okay. Okay. So by varying rho and phi, what is the surface you are going to get? You are going to get the surface area of a circle, isn't it? Right? And what is the direction of that surface here? The direction of the surface is given by the unit normal drawn to that surface. So if you draw the unit normal to this circular surface, it is pointing in AZ cap direction, right? Okay. So now we do it mathematically here. Now we do it mathematically. So now see here. So if you want the total surface area, what you have to do? Here what are variables? Rho and phi. So integrate with respect to rho and integrate with respect to phi. So rho d phi az cap. Okay. Okay. So let us say rho is varying from rho. The range of rho is from 0 to infinity. Understood? So I am limiting the rho range here, that is I am considering rho is varying from 0 to rho 1. I am considering rho is varying from 0 to rho 1, right? And phi is varying from 0 to what? Phi is varying from 0 to 2 pi. Phi is varying from 0 to 2 pi. So if you do this, what you are going to get? Do the integration. Integration of rho d rho is nothing but what? Rho square by 2. Its range is from 0 to rho 1. Integral d phi is nothing but phi. Its range is from 0 to 2 pi and it is pointing in az cap direction. So if you substitute the range, what you are going to get? You are going to get rho 1 square by 2 here, and here you are going to get 2 pi here, and here you are going to get az cap. So here 2 will get cancelled. You are going to get what? Pi rho 1 square into what? Into az cap. So this represents what? Pi rho 1 square represents what? Represents the surface area of a circle or not? Yes or no? It represents the surface area of a circle whose radius is rho 1. Right? Okay? Okay. So without doing this mathematical analysis, we have visualized what is the surface going to form by varying rho and phi. Understood? Okay? Okay. So similarly, we try to determine another differential area. So always write down the differential lengths here, right? So d rho a rho cap, rho d phi a phi cap, and dz az cap. Okay. So next differential area dA2 bar is equal to. So do the cross product between these two here. What you are going to get? Rho d phi a phi cap cross what? Cross dz az cap, which is equivalent to what? Which is equivalent to rho d phi into dz a phi cap cross az cap is nothing but what? Is nothing but a rho cap. So here what are the variables? Phi and z are variables. So rho is constant. Rho is constant. So we call this plane as a rho equal to constant plane. We call this plane as rho equal to constant plane. So for rho equal to constant plane, what is the direction here? Its direction is along a rho cap. Understood? So if you are enclosing the surface from a phi cap to az cap, in that case you are getting the direction as what? A rho cap. Right? Okay. So here the variables are nothing but phi and z. So here rho is constant. So we call it as a rho equal to constant plane. Okay. So now we try to determine the total surface area. The total surface area. So now similarly as we have done previously, so here also we try to visualize what is the total surface that we are going to get by varying what? By varying phi and z. Here rho is constant. Understood? So keep rho constant and vary phi and z and guess what is the surface that you are going to get. So pause the video and guess the surface. Right? Okay. I hope you have guessed that surface. So now we try to visualize. Right? Okay. So this is z axis. This is z axis. So this is rho. Rho is fixed. Right? Rho is fixed. Now vary phi and vary z, vary phi and vary z, vary phi and vary z. Right? Okay. So rho is fixed here. Let us say this is z axis. Right? Here z axis is present. So rho is fixed. Okay. Now you have to vary phi and vary z, vary phi and vary z, vary phi and vary z. Right? So vary phi, vary z, vary phi, vary z, vary phi, vary z. So what you are going to get? You are going to get the curved surface of the cylinder, isn't it? You are going to get the curved surface of the cylinder. Right? So what is the curved surface area of the cylinder here? What is the curved surface area of the cylinder? We have already seen. What is the curved surface area of the cylinder? Is nothing but what? 2 pi rho times h. So here h is nothing but z. So you have to get 2 pi rho times z. Understood? Okay? Okay. So now see here. So let us check mathematically what we are going to get. So in order to get the total surface area, what you have to do? You have to integrate with respect to phi, and here you have to integrate with respect to z. So phi is varying from 0 to what? 0 to 2 pi, and z is varying from let us say 0 to what? 0 to z1. So here you are having rho d phi dz a rho cap. So this is equivalent to, right? Here rho is constant with respect to integration variables. So you can take rho outside here, outside the integration. Next you are having integral d phi. Integral d phi is nothing but phi. Its range is from 0 to 2 pi. Next integral dz. Integral dz is nothing but z. Its range is from 0 to z1. So if you do this, what you are going to get? Here rho, here 2 pi, here you are getting z1, right? And here the direction is what? The direction is along arrow cap. So here what you are going to get? 2 pi rho into what? Into z1, and its direction is arrow cap. Okay, so 2 pi rho represents the circumference of the circle, z1 represents what? Height. Understood? Okay, so 2 pi rho times z1 will give you what? Will give you the curved surface area of the cylinder. So the shape of the surface here, we got it as what? We got it as curved surface area, the curved surface area of the cylinder. So its height is z1, and its radius, so let us say this is z axis, right? And its radius, the radius of this one is nothing but what? Is nothing but rho, right? So we got the curved surface area of the cylinder, right? And what is its direction here? Its direction is arrow cap. So here this is rho, and if you draw the normal to this curved surface, it is going to point in which direction? It is going to point in arrow cap direction. Okay, so this is arrow cap direction. Okay, so if you are having a curved surface, and if you draw a normal to that curved surface, it is going to point in which direction? It is going to point in radial direction, that is arrow cap direction. Understood? Okay. So we have seen the second surface area also, right? Next, what is the third surface area here? So always write what I have told, always write the differential lengths. Rho d phi a phi cap dz az cap. Now what is the third differential area? dA 3 bar. Okay, so is equivalent to what? So do the cross product between dz az cap and d rho arrow cap. So dz az cap cross what? Cross d rho arrow cap is equivalent to what? dz into d rho into az cap cross arrow cap is nothing but what? Is nothing but a phi cap, right? And here the variables are nothing but z and rho. And hence we call it as what here? Phi equal to constant plane. Here phi is constant and z and rho are varying. So we call this plane as what here? We call this plane as a phi equal to constant plane. And for phi equal to constant plane, what is its direction? Its direction is a phi cap. We are enclosing the surface from az cap to arrow cap. So in that case, the direction of the surface is pointing in a phi cap direction. Okay. So I hope it is crystal clear, right? So now see here, what is the total surface area you are going to get? Here it is very simple here. So here the variables are nothing but only z and rho. Right. See, as you move along z, you are going to move along a straight line path. Yes or no? In upward direction. So if you move along rho, right, so you will move along a straight line path, yes or no, which is parallel to xy plane, isn't it? Okay. So if you move along rho, you are going to move along along a straight line path parallel to xy plane, and if you move along z, you are going to move perpendicular to what? Perpendicular to xy plane like this. Understood? So if you vary z and if you vary rho, and if you vary z, what is the surface you are going to get? If you multiply these two, what you are going to get? You are going to get the surface area of what? The surface area of a rectangle. The surface area of a rectangle. Understood? Okay? Okay. So if you vary simply rho and z, you are going to get the surface area of a rectangle. So it is very simple here, right? Okay. Okay. So now here integrate with respect to z and integrate with respect to rho. Let us say z is varying from 0 to z1 and rho is varying from 0 to rho 1. Here dz d rho a phi cap. So which is equivalent to what? Which is equivalent to, so integral dz is z. If you substitute the range, I am going to get z1, and integral d rho is rho. If you substitute the range, I am going to get rho 1. So rho 1 into z1 is nothing but what? Is nothing but the surface area of a rectangle. Understood? And its direction is what here? Its direction is a phi cap. So rho 1 z1 into a phi cap. So this represents the surface area of a rectangle. Now see here. So this is the cylinder here. This is the cylinder. Let us say this is the cylinder. Okay. This is the cylinder, and this is z axis. And here you are having x axis, and here you are having y axis, right? Okay. Okay. Right. Okay. Okay. So now see here. Now let us consider this point. So this is what? This is rho, right? Okay. So now I am moving from this point to this point here. I am moving from this point to this point. So this radius is also what? Rho, right? So this is rho, and this is nothing but what? This is nothing but z. Let us say this is rho 1 here. Let us say this is rho 1 and this height is z1. This height is z1. Okay. So this rho 1 into z1 will form what? Will form this surface area. Will form this surface area. Understood? Okay. So rho 1 into z1 will form the surface area of a rectangle. And what is the angle? What is the angle made by this surface with respect to x-axis here? See, the angle between x-axis and this one is nothing but what? Is nothing but phi only. Yes or no? So if you measure the angle here, just draw a line parallel to x-axis. If you measure the angle, you are going to get what? You are going to get same angle phi. So if you draw a line parallel to x-axis and if you measure this angle, what you are going to get? Phi only. Okay. So that means on this plane, wherever you will move, this phi is not going to change. So that's why we call this as what? We call this as phi equal to constant plane. So on phi equal to constant plane, what are variables? Rho is variable and z is variable. Understood? Okay. Whereas phi value will be same. So that's why we call it as a phi equal to constant plane. Right? Okay. So I hope it is crystal clear. I hope it is crystal clear. Right? Okay. Next. So next concept is we have to determine the differential volume. So in order to determine differential volume, what we have to do? D rho a rho cap, comma, rho d phi a phi cap, comma, dz az cap, right? Okay. So what I have told here, in order to determine the differential volume, what I have told? So take any surface, take a small differential surface and extend that surface in its perpendicular direction. Then you are going to get what? You are going to get the volume. Okay. So that is the concept we have followed in rectangular. So here also the same concept we are going to follow. So I can write differential volume dV is equal to, I am going to consider one surface, a small differential surface. So I am doing the cross product between these two here. So if you do the cross product between these two, what you are going to get? D rho d phi aero cap cross a phi cap is nothing but what? Is nothing but az cap. So this is the small differential area that we are going to get. This is the small differential area that we are going to get. Understood? So here what are variables here? Rho and phi. So rho and phi are variables means here you are going to get a small differential area on the surface of what? On the surface of a circle. Isn't it? Yes or no here? Okay. So if you vary only rho and phi, what is the surface you are going to get? You are going to get the surface of what? You are going to get the surface of a circle. Understood? We know that one. So if you consider a small differential area on the surface of what? On the surface of a circle. Right. Now if you extend that surface of a circle along z direction, you are going to get what? You are going to get the volume of the cylinder. So if you take a small differential surface of a circle and if you extend that surface area of a circle by dz units, okay, what you are going to get? You are going to get the volume of a cylinder. Yes or no? See, if you place the circular rings one upon the other up to some height h, you are going to get the curved surface of the cylinder. Similarly, if you place circular discs instead of circular rings, if you place circular discs one upon the other up to some height h, you are going to get what? You are going to get volume. Okay, so we have considered a small differential surface area on the circle, right? And we have extended this small differential surface area in z direction by dz units. So you are going to get a small differential volume, Understood? Okay. Okay. So now see here. So take any small differential area and extend it in its perpendicular direction. You are going to get the differential volume here, right? Okay. So we have already seen. So you have to extend this small differential area in its perpendicular direction. So that is along dz az cap direction. Okay. So what you have to do? You have to do here dot product. We have seen already these things here. Whatever we have followed in rectangular coordinate system, the same thing we are following here. Right? Okay. So if you do this, what you are going to get? You are going to get rho d phi into what? Into dz. Just multiply all the three differential lengths here. Okay. So just multiply the coefficient of aero cap, coefficient of a phi cap and coefficient of az cap. Okay. You are going to get what? You are going to get the differential volume. Now if you want the total volume, what you have to do? You have to integrate with respect to rho, and you have to integrate with respect to phi, and you have to integrate with respect to z. Understood? So here rho d phi dz. So let us consider rho is varying from 0 to rho 1, some finite value of rho I am taking, and phi is varying from 0 to 2 pi. I am taking full range of phi, and z is varying from, let us say, 0 to z1. So if you do this, what you are going to get? You have to get the volume of what? The volume of the cylinder. Yes or no here? So if you vary rho, phi and z, right? So what you have to get? You have to get the volume of the cylinder. So let us check what we are getting. So integration of rho with respect to d rho is nothing but what? Rho square by 2. Its range is from 0 to rho 1. Integral d phi is phi. Its range is from 0 to 2 pi. Integral dz is z. Its range is from 0 to z1. So if you do this, what you are going to get here? Rho 1 square by 2 into what? 2 pi into what? Into z1. So here 2 will get cancelled. So what you are getting? Pi rho 1 square into what? Into z1. Pi rho 1 square into z1. Right. So pi rho 1 square represents what here? Pi rho 1 square represents the surface area of a circle. Understood? So if you place circular discs here, okay, one upon the other up to some height h, what you are going to get? You are going to get volume of the cylinder. So what is the volume of the cylinder? So the surface area of a circular disc is nothing but what? Pi rho square. So such type of circular discs you have placed one upon the other up to some height h. Understood? Then volume of the cylinder will be pi rho square times h. Understood? Here in place of h we are having what? We are having Z1. That is the only difference, right? Okay. Okay. So what is the volume of the cylinder we got? The volume of the cylinder we got it as what? Pi rho 1 square into what? Into Z1 into Z1. Or you can simply say pi rho square into Z. So that is the volume of the cylinder. So what is the concept here? How we can determine the volume? So take any surface and extend that surface in its perpendicular direction. Then you are going to get the volume. Understood? See, in case of cylindrical coordinate system, how many surfaces we got? 3 surfaces. What is the first one here? What is the first surface? So the first surface is z equal to constant plane. Z equal to constant plane. So here I am drawing the cylinder here. Okay. So some rough diagram. So this is z equal to constant plane. Z equal to constant plane. Right. So these planes here, all these circular planes are nothing but what? Are nothing but z equal to constant planes only. All these are nothing but z equal to constant planes. Okay. So as you move along this circular surface, what are going to vary? Rho and phi. Rho and phi are variables on these surfaces. Understood? Okay. That is z equal to constant planes. Right. Next. So what I have told here? So take any surface and extend that surface in its perpendicular direction. You are going to get what? Volume. Yes or no? Now here z equal to constant surface represents what? Z equal to constant surface represents the surface area of a circle. Understood? Now if you extend this surface area of a circle in its perpendicular direction is az cap. So if you extend this surface in its perpendicular direction, what you are going to get? You are going to get volume of the cylinder. That is the concept here. That is the concept. Take any surface and extend that surface in its perpendicular direction. You are going to get the volume. Right? So here we are having in cylindrical coordinate system, we are having 3 surfaces. So if you extend this z equal to constant surface in its perpendicular direction, we are going to get the volume. Z equal to constant surface is nothing but what? The surface area of a circle. If you extend this in its perpendicular direction, you are going to get the volume of the cylinder. So similarly, if you consider A2, so this is nothing but what? This is nothing but rho equal to constant plane. So rho equal to constant plane means what here? What are variables? Only phi and z are variables. So let us take rho equal to 0. Okay, so if you take rho equal to 0, you are going to have what? 0 cylinder. Right? See, if you vary phi and z, what you are going to get? You are going to get a curved surface of the cylinder. Yes or no? Let us consider rho equal to 0. Rho equal to 0 means you are getting 0 cylinder, no cylinder at all. Okay. Now just increase rho here. Just increase rho. Right? Okay. So just increase rho. Let us consider some small rho. Okay. So with this rho, if you vary phi and z, you are going to get what? You are going to get a small cylinder like this. Understood? Now if you extend this surface along its perpendicular direction, what is its perpendicular direction? That is aero cap direction. For rho equal to constant plane, what is its perpendicular direction? Is nothing but aero cap direction. So if you extend this surface in its perpendicular direction like this, right? So in its perpendicular direction like this. Okay, like this. What you are going to get? You are going to get the volume of the cylinder. See, it is just like placing the concentric cylinders one after the other. Right. So first take rho as very small. Okay, you are going to get the small curved surface of the cylinder. Now you have to extend that. You have to extend in its perpendicular direction. So that is in aero cap direction. Understood? So if you extend that in aero cap direction, you are going to get what? You are going to get the volume of what? The volume of the cylinder. It's just like placing the concentric cylinders one after the other by varying rho. right? Okay, so take this small surface and extend it in its perpendicular direction. You are going to get the volume of the cylinder, right? Okay, next what is another surface we are having? So another surface, rho equal to constant surface is completed. Next, what you are having? Z equal to constant surface, sorry, phi equal to constant surface. So this is nothing but phi equal to constant surface. Understood? Okay, so this is nothing but a rectangle here. Phi equal to constant surface is nothing but a rectangle. And what is its direction here? Its direction is in a phi cap direction. So a phi cap direction. So if you draw the normal, to this plane, it is going to point in a phi cap direction. It is going to point in a phi cap direction. Understood? So if you extend this surface in a phi cap direction means you have to rotate this rectangle in which direction? In a phi cap direction, like this. Understood? So if you rotate this rectangular surface in a phi cap direction, that is in anti-clockwise direction, like this, then what you are going to get? You are going to get the volume of the cylinder. Isn't it? So like that, take any surface here. Take any surface and extend that surface in its perpendicular direction, then you are going to get the volume, right? And here we are having three surfaces, so you can extend any of these three surfaces in their perpendicular direction, then you are going to get the volume, right? Okay, so that is the conclusion we can make, right? Okay, so with this we have completed the cylindrical coordinate system. With this we have completed cylindrical coordinate system, right? Okay, so this is the end of the cylindrical coordinate system. So in the next lecture we are going to start spherical coordinate systems, right? Okay, so I hope this cylindrical coordinate system is crystal clear. Okay, so okay then, take care, bye bye, and thank you for watching.